Hi everyone, so welcome back to National Chemistry. Today we're going to be looking at lesson 6, which is properties of covalent compounds. So we have already looked at ionic compounds. Today we're going to be talking through some properties of covalent ones. For your starter though, I want you to write a summary of the properties of ionic compounds, including structure, melting and boiling point, and conductivity, please. This will be worth 1 mark each. Just to make sure that everybody understands the properties of ionic compounds before we move on to covalent, because we have to keep these two types of bonding totally separate in our minds. So we're going to have a wee look at the properties of covalent substances. Think about some properties we already know, like melting and boiling point, and what these actually mean in terms of properties for bonding structures. And we want to be able to, by the end of this, identify the type of bonding by looking at the properties. So let the properties decide for us, is this going to be ionic or covalent bonding, and what are the types within those two categories. So, covalent compounds, a little bit of revision, we haven't done this in a couple of weeks. Molecules are made up of which type of atoms? Non-metal atoms, which are covalently bonded together. So if you remember from before, covalent bonds are a shared pair of electrons between non-metal atoms. Do non-metal atoms usually conduct electricity? The answer is no, they don't. So the question is, do you think that covalent compounds conduct electricity? There are some examples below. You've got CO2, carbon dioxide, chlorine, water, and glucose down there as well. So have a wee look at those. They're all made up of non-metal elements. What do you think? Do covalent compounds conduct electricity? The answer to that, of course, is also no. Covalent compounds do not conduct electricity in any state. So it's not like the situation with ionic substances. If you dissolve them or melt them, they conduct electricity. Covalent compounds never, ever, ever conduct. Now, there are 2 small exceptions that I want to speak to you about. The first one is water. You might be thinking, water's up there, it's made of hydrogens and oxygens, which are non-metals. How come water is very dangerous around electricity? You'd be absolutely right to ask that question. But the answer is, water only conducts electricity because of the ions that are present in it. So remember from the acids and alkalis topic, water is made up of very few numbers of ions and lots of water molecules. But it is these ions, so the hydrogen ion, H+, and hydroxide ion, OH negative, they are responsible for allowing water to conduct electricity just a little bit. So that's the first exception. The second one is carbon in the form of graphite. Now that is the exception that you're going to have to memorise. That conducts electricity for a very special reason, and it's because there are delocalised electrons in the structure. Now you don't need to worry about that too much. All that means is that it's allowed to conduct electricity because there is a charged particle, i.e. the electron, and delocalised simply means that the electrons are allowed to move around. So we already know that electricity is a flow of charged particles. So if there's electrons in the structure and they are being allowed to move around, then that means that carbon in the form of graphite can conduct electricity. So we have to kind of identify the structures of covalent compounds. So you have a little note to take here, which is properties of covalent substances. So just a wee couple of reminders. Non-metal atoms bonded covalently together make up molecules. Covalent substances do not conduct electricity because obviously they are made up of non-metal atoms. However, carbon, a non-metal in the form of graphite, does conduct electricity. That's your example I want you to memorise. And covalent substances can be placed into 2 categories. More on those 2 categories in the next section of the video. I want you to copy that note into jotters just now.